Hi friends, I'm Dr. Sagir. Today I will show you some interesting electronic projects using microcontrollers and sensors. Welcome to the amazing world of microcontrollers and sensors. A microcontroller is a special type of microprocessor which can be programmed to execute your commands. A microcontroller can be programmed using high-level language. Actually, a microcontroller connected to a machine recognizes a machine language. So we use a computer to program it to execute our commands. This is a microcontroller augmented board. It's called Arduino Uno. Arduino is an open source electronics prototyping platform. There are different models of Arduino Uno. Later I will show you different types of Arduino boards. A microcontroller in this Arduino Uno, they uses the famous Atmel's ATMega 328 microcontroller. A microcontroller has got a lot of input and output pins or ports. The sensors are connected to the analog inputs of the microcontroller, and this analog data means it read in terms of voltage differences. That's called analog data. This analog data is converted to digital data. It's called analog to digital conversion. You can see this microcontroller embedded in many systems around you. For example, in a car's fuel injection system, you can see this microcontroller as a customized embedded system. Even you can use this microcontroller to network your home's entire security system. Today, in this video, I'll show you some interesting projects like a robot, a programmable robot that obeys the commands you give through your Android phone, and a LED cube. This is an LED cube. It can be programmed. This is an autonomous or obstacle avoiding or avoidance robot. In this robot I have used different types of servos and gear motors. The main attraction, the head portion, is an ultrasonic distance measuring sensor. You can see with my hand I can control the robot. This is a Bluetooth controlled rover or robot. You can see a Bluetooth module paired, and you can control it with your Android phone, or it obeys through voice commands. You can see in this video even the motion sensor of your phone can be used to control it. I have used right angled or offset shaft bore motors as the main two engines.
Left, right, stop, forward, stop,
This is a robot. Here I used a breaker board, and the IC here used is LM293, and this is the microcontroller ATMega 328. This is a breakout board, and I have assembled all these components on a breadboard. And this is a small micro servo, a servo motor. It controls the neck portion and the head of this robot, and this head is a sensor. It's an ultrasonic sensor. It measures the distance. It's the distance measuring ultrasonic sensor. It moves like this. Below you can see a 500 RPM gear motors. I have used huge power source for this robot. A 12-volt battery powers the big gear motors, and two 6-volt batteries supplies this main brain, this breakout board. This is a robot. It moves using two servo motors. This is servo controlled. Actually, with this gear motors, you can control the direction only with the using H-bridge breakout board. But with the use of a servo, you can control the speed of the servo. It's amazing. This is a Bluetooth controlled robot. Actually, I made it from a scrap cardboard. It uses two right-angled bow motors. The breakout board, the H-bridge is IC LM293D. This is the Bluetooth module. You can see it, the Bluetooth module. It is less noisy. Actually, it generates a little electricity. This is an LED cube. Soldering this LED is really a challenge. It took 4 to 5 hours to complete this cube. This is a radio, a world receiver, using many controls on board. This is a world receiver which I have made from a scrap food plastic container. It has got many controls here.
m.voanews.com/Kurdish أما مالقرية تايبكية بوئي وبرقاي موبايل كانتان بتوانن سردان
This is a signal attenuator and band switches and the bandwidth adjuster, a fine tuning. What you're hearing is Voice of America.
أيضا جتان لبرنامج كاني بشي كودي راجي ضني أمريكايا كروجانا وماوي سي كاجمير برنامج كمان بريتي دبيت لدو بيانزي بياني يكي دواني ورو بو دوي دواني ورو وهروها برنامج كان دوبارة لكاجمير سي دواني ورو.
The signal sensitivity is high, but the selectivity is poor due to heavy monsoon rains outside.
നാം പലപ്പോഴും വേട്ടയാടുന്നത് അവിഹിത മാർഗങ്ങളിൽ നിന്ന് അകന്ന് ജീവിക്കുക. ഇതാണ് ഭയമുക്തിക്കുള്ള മാർഗം.
The bit resolution of a microcontroller is mainly meant for the input pins, because whatever we connect to the input, for example a sensor, it receives the analog input and transform to digital, the binary. The output pins need only 2-bit resolution, 2 bytes. That means 0 and 1 binary digits, 0 for off and 1 for on. So the output pins of a microcontroller actually on and off the output device, and it also uses the PWM method, pulse width modulation. The pulse width modulation is nothing but it reduce, it decrease and increase the voltage level. Very simple. That's the secret of a microcontroller. To bootload the blank microcontroller ATMega 328, you need the microcontroller ATMega 328, blank microcontroller, and some electronic components. You have to breadboard the components or assemble the components on a breadboard. These are crystal, 2 sizes. This is 16 megahertz quartz crystal. You need only one. And this is voltage, 5 volt voltage regulator. and 20 dp of capacitors, ceramic capacitors, and push button switches, micro switches, only one needed, and resistors. This is MF metal foil resistors, 10 kilo ohms and 220 ohms. This 220 ohms need to connect this LED to the breadboard. One LED to connect to the power rail to check the power of the microcontroller board, and this one to connect to the SCK pin, that means pin number 19 of the microcontroller, and 10 mF electrolytic capacitor. These are the components needed to breadboard the microcontroller. You can use different types of breadboards. This one is a compact one, and this is another type. This is a bigger one. It has some positive negative terminals to connect the ground and the positive voltage. To connect the components, you can use hookup wires. You can use 22 or 21 gauge hookup solid single strand wires, and jumbo wires like this. This male to male jumbo wire. To connect your breadboarded microcontroller to the computer, to make serial communication, you need FTDI or USB TTL converter. This one is cheaper compared to this FTDI. If you use this one, USB to TTL converter, the IC PL2303HX, you have to connect a 104 or 100 NF or 0.1 MF capacitor. This is a ceramic disc capacitor to the pin number 2 of that means the reset pin of the IC. It's a little bit tedious process because a tiny drop of molten lead will short all the legs because the legs are so closely arranged. So better you use lead paste instead of solid wire lead. This paste, you can use hot air gun to place the capacitor and solder a jumper wire to the other leg of the capacitor, and so you can easily connect it to the breadboard. You can check the LEDs, so broken LEDs, with the help of a 3-volt button cell. You can use a IC puller to handle the microcontroller. Otherwise, the legs of the pins of the IC will be deformed due to mishandling. So be careful to use a IC puller. Take the breadboard, now gently place the IC or the microcontroller on the breadboard. and press it. To do this, you have to bend the pins of the IC a little bit. You can do it by gently pressing the pins together on a rigid surface like this, using your thumb. Or you can do it by simply pressing with your index finger and thumb like this, and now place it on the slot. Before that, watch the correct IC position. There is a notch here. Place it rightly. Now it is placed on the breadboard. Now do other connections. Take some hookup wire, 21 or 22 gauge, as I said earlier, and strip it with a wire stripper. Bend it with a long nose plier. Now you can place it. The red wire goes to the positive terminals. It connects the positive rails of the breadboard. The completed Arduino look like this. The Arduino official website explains all this procedure step by step in detail. You can visit the Arduino official website. Connect the USB cable to the FTDA breakout board or the basic board with the FT232 RLIC on board. And connect it to the master augmented board with the master microcontroller. Now connect the other end to the computer. It is connected to the master breakout board, and you can connect this thing. This is the breadboard This is a breakout board we have made earlier. Now make some connections between these two ICs so that you can use the ISP programming method, in-system programming method. First, connect the pin from the master microcontroller, 16 number pin, to the reset pin of the slave microcontroller. Now connect from pin number 17 to 19, that means 3 connections, to the same 17 to 19 pin numbers of this microcontroller, because here I have used both the master and the slave microcontroller on breadboard method. So there is no pin number confusion. You can connect directly up to 17 to 19 of both microcontroller pins. I'll show you. This goes to 17. Next one. $18. Next one. Oh, I made a mistake. Okay. The next one, the blue one, goes to the pin number 18. I mean 19. Okay. Then power it up. You can use. There is no need of concern for pins. You can directly give the positive and negative, the ground and the positive voltage of the both rails together. Now you can see it lights up. Now you can open the IDE program and you can bootload it very easily. Open the Arduino IDE Interactive Development Environment. Here I use version 1. And select ISP in system programming from examples. And tools, serial port, select it, Arduino Uno board, and program Arduino as ISP. Then upload it. Press burn bootloader button. Bootloading. And the two boards are communicating. Master and the slave microcontrollers communicating fast. Lights are blinking very fast on both boards. Now the bootloading is completed. We can also use a breadboard, small breadboard like this with basic assembly, the microcontroller crystal and two grounded capacitors 22pf to bootload the microcontroller. I have tried both methods and I found this method more reliable compared to this one. It's very fast to bootload. The success rate is very high to this detail board. Here I used an FTDI module to communicate with the master breakout board or the augmented board. Most of the people use the original Arduino board or the clone to as a master breakout board. Here I used the master and the slave. The slave is which we have breadboarded earlier. Both are Arduino Uno on breadboards. That's very important. Here the FT232RL FTDA module has been used. You can also use this serial communication method for machine to machine communication end-to-end all and debugging using I2C or I2C method. To check the bootloader ATMega 328, we need to upload the basic blink test. Here I have used the USB to TTL converter, the modified converter. I have soldered a 100 enough capacitor to the PL2303 HX IC on board. The four wires, of these four wires, the red goes to the positive voltage, negative grounded, and the TX goes to the RX, and the RX of the converter goes to the TX of the ATMega 328. I'm connecting the board to the computer. Now the LED connected to the pin number 19 does not blink, so we need to upload the sketch. File, examples, basics, blink. Now upload the sketch. It's compiling. See the changes on the breadboard. It's trying to communicating, prompting something. For the port, click OK. Now watch what's happening. It's communicating with the microcontroller. Now it has started blinking. Everything is okay. Now we are going to upload a little bit bigger sketch. See this LED cube. I am going to program it. Now I have connected all the wires, all the jumbles to the board and the LED cube. I'm going to program it. This is a sketch. I upload it. Uploading. You see the changes. You see the changes. Now you can detach it from the computer. Remove the USB converter. You can keep an external power supply. This is 6 volt. Arduino need only 5 volts. So it will act as an independent, customized, multiplexed LED cube. This is a programmable LED cube. You can make any pattern, absolutely any pattern you can make it through programming. Now I am going to test the standard rotation servo. This is standard servo. Here the Arduino IDE I have opened it and included the library servo H. Include the servo library, and here the void loop section. This function, void loop function, the servo write is 40. Actually a standard servo is made to rotate in between certain angle. It won't rotate continuously, so later we need to convert it to a continuous rotation servo so that we can use it for the wheels of our robots, autonomous or other purpose robots. So I'm going to change the value 40. Watch this, 42. $180. Uploading. Watch the servo moving. Just compiling. Uploading. It rotated certain angle. Now I'm going to change to the previous position. I'm going to rotate 120 degree back to 40. I'm going to change the value of servo write to 40. Uploading. Watch this. Compiling. Uploaded. So for a standard servo it won't rotate continuously, so I will show you how to make a continuous rotation servo out of this standard servo. For continuous rotation, the value here in the servo write, it is 0 or 360. So let us watch. If I write 0 here, what will happen to this standard servo? Uploading. It's making some noise. The feedback system is jamming. It got in a state of confusion. There is a feedback system inside the servo. When I wrote 0 here, we found that entire feedback system inside the servo went to a state of jamming. So now here the 0 write, I'm going to write 360. As I said earlier, 0 and 360 are the two value for continuous rotation. So now I am going to change the value to 360 and let's watch what happened. Uploading. Again some noise inside. So according to the test we have done, we need to make some modification to the standard servo. Actually, this is a potentiometer, a small potentiometer with a metal shaft. I took it from this inside of the servo. We have to remove it to make it continuous rotation servo. Let us check the value of the potentiometer. Approximately 5 kilo ohms. So we have to solder. First of all, open the back case of this servo. I will show you the exact video and the pictures of the procedure, and remove this potentiometer. You can press it from the top end, gently press it. Before that, you have to take the glue. There is a drop of glue inside it. Remove it with a sharp instrument and press it so it will come out. And instead of this, add 1.5 kilo ohms resistors. Solder it so that it will make a voltage divider. It's a main part of the, like this. This is a main part of the feedback system. Without this voltage divider, this servo won't work. Unscrew the 4 long screws so that the top and the bottom end will be separated. Now you can see 4 gears, the bigger one and the 3 small ones. In the picture you can see a stop on the bigger gear, the main stop behind the shaft portion of the main gear. Remove it, cut it with a fine sharp knife. Now you can see 3 wires connected to the potentiometer. Cut these wires and add a voltage divider. Join the voltage divider resistors to place inside the servo. So it must be very small. The tag portion must be very small. After soldering, cut the tag portion. Look like this. Cut the tag portion, excess portions. Gently bend it so that it will become more compact. Cut the tags. So the finished voltage divider resistor combination looks like this. We have 3 connections here, and connect these 2 ends of the resistors to the 3 ends of the resistors to the 3 cut wires inside the servo. Once again, I am going to test the value 0 and 360 in the servo library. I have to upload the sketch to the modified servo. I have removed the potentiometer and the stop. I cut and removed the stop, which prevented the continuous rotation of the servo. Open the IDE file, examples, servo. Now here the value 360. Upload, compiling. Let's watch on the breadboard. Watch. .360 is comparatively fast. Now we are going to change the value. To 0. Uploading. Let's watch the changes on the rotating, spinning servo wheel. Uploading. Stopped. Watch. It's rotating anti-clockwise, clockwise and anti-clockwise in the opposite direction. .360 servo right 360 rotated in the anti-clockwise and 0 rotates it in clockwise direction. See the difference. Now I am going to adjust the speed of the servo by servo right. Going to change the value. Watch this. Let me put the value 10. Uploading. Compiling the sketch. Let's watch the difference. It's slightly reduced. Now let's try another value. Let us put the value 80. Uploading. Look at the breadboard and the spinning wheel. stopped. Now it's uploading. Begin slow for the value 80 servo height. Now let's try the value 90. Let's see what's happened. Uploading. Totally slow, very slow. Let's try the value 95. Again, very slow. In this way, we can control the speed of the continuous rotation servo, the modified continuous rotation servo. If you use different type of sensors and components for your Arduino robot, you have to meet additional power necessities. For example, in this robot, this is an autonomous obstacle avoiding robot. I have used this ping sensor, passive, this is called ping sensor, ultrasonic distance measuring sensor. It's connected to the brain, the microcontroller of the robot. Such devices takes a lot of power. This is an infrared PIR, passive infrared sensor. You can use it for obstacle avoidance, but you have to find the additional power needs. For example, this breakout board, they use an voltage regulator, and you can tap 5 volts out of this. So try to use such power onboard power outputs, so you don't need unwanted additional power sources. Next time, when your 9-volt battery shows charge down. Don't throw it away. Your Arduino can take the remaining juice because the logical volt input for Arduino is only 5 volts. Watch this. This battery shows 8.31 volts. Connecting to the Arduino. Watch now. It's working flawlessly. Actually, servos are greedy eaters of power. So if we use 2 or more servos or gear motors, we can use current amplifying ICs like this. This is LM293D breakout board. The IC LM293 on board. Actually, we can stack these ICs one above other to get more power amplification. We can stack one above, that means parallel connection. This one is the famous LM298 breakout board with the 293 IC. You can see here with a very big heat sink. It dissipates a lot of heat energy. If you want to make humanoid robots or more powerful rovers, like obstacle avoiding robots or autonomous robots, you need this breakout board, current amplifiers. It's an absolute necessity. Arduino is an open source developing or prototyping platform. You as a developer or prototyper, you have to do a lot of experiments. You can modify the software. You have to check the compatibility of software and hardware. Here I will show you how to check the serial communication device or the USB to TTL converter, whether it may be FTDI or USB TTL converter. It has RX and TX pins, so just place a jumper like this on the RX and TX pins, short it. Be careful, don't short ground and positive voltage pins. Just place like this. Now we connected the RX and TX pins together. Connect the other end to the computer. Now open the Arduino development environment, the IDE. Open the serial monitor. Now you type something on the keyboard. Press enter. Now you can see it's on the serial monitor. check again. You can see here, so it means your serial communication board is working properly. Now you can try communicating with the Arduino you have made. If you find it difficult to make Arduino Uno on breadboards like this, you can easily buy one like this. The original Arduino Uno comes from Italy. In Italian, Uno means number one. This is world's DIY community's favorite microcontroller board. This is revision 3 board. In previous boards, they have used the FTDI IC for the second IC. Here, this is version 3, revision 3. The IC used is Mega 16U2 SMT. Instead of in-circuit system programming, you can easily remove this IC from here for programming and other purposes. If it is damaged, you can replace it. It's fixed in a IC base or socket. In all other Arduino models, it's fixed to solder to the board. Here the second IC Arduino used is a newer modified SMT Mega 16U2 IC for serial communication. In the previous board they had used FTDI IC for this purpose. Let me magnify it for you. Actually, there are two microcontrollers on Arduino board. The second one is very tiny, so you won't notice it. It's used for serial communication. This is a magnified image of the IC Atmel Mega 16U2. You can read it easily. The bigger one, the main microcontroller, is ATMega 328P or 328. To make your LED projects, whether it may be normal LEDs or using special LED matrices like this, is an RGB LED matrix 8x8 common anode. So this is single color red 8x8 common cathode LED matrix. This is a common anode 7x5 LED 5x7 LED matrix, and common anode 7 segment LED display. These displays you can use shift registers or drivers, shift registers and drivers to make your LED projects more spectacular. This is a Maxim's Max 7219 LED driver, and the second one is shift register ULN2A03, and the third one is the LED driver SN74HC59. To make an LED cube like this, you have to solder all the LEDs in rows and columns. For that, to make it easy, we can use a board, a perforated board like this. I have used a scrap plastic board I collected from a junk room, and you can place some holes here with equal distance and place the LED inside that and solder the joints, anode and cathode together. According to the columns and rows you want to make. Here this is a 4x4x4 cube. I have used 64 LEDs, a double color, green and red. In my next video, I will show you how to make a simple world receiver with simple controls like this. Actually, I used a scrap cardboard box as the chassis, as the body of the radio, and you can see the main component of this well receiver is a circuit board inside this with two ICs inside. This is the very important component of this radio. It's a OA79 diode. I collected it from an old junk radio, very precious piece of electronic device for me. Actually, I breadboarded it first. This is a circuit of this component layout. You can see two ICs here. One is audio amplifier. This is the signal demodulation. Hi friends, thank you for watching my video.